be talking about building a real-time web. My name is Arnout Kazemier. I'm one of the core developers of Socket.io. I also work for Nojitsu as lead software engineer. You can follow me on Twitter, and if you add a dash in the middle, you also have my GitHub handle. So why would you implement real-time in the first place? It has a lot of benefits that maybe it's not obvious to a lot of people, besides being total badass, of course. One of the things can be an increase of time on the site. When you are having new content that come up on your site every single second, you will have people that stay longer on your site. They will not need to refresh. They can just keep your browser open and just look at it when they have the time for it. A good example of this is the Twitter timeline. When you have no apps open and you only have a browser, you will just open up the Twitter timeline and see your tweets coming in and just keep it open. Another reason would be decreasing the server cost. If you have a lot of new fresh content coming in and you have a lot of users refreshing your page, they will actually be refreshing the whole page instead of just receiving a little bit of information. So you will be executing a lot of new database requests, getting in a lot of new data from your database. And that might not sound like a lot, but if you are working on a larger scale application, it will count up really fast. Another reason why you might want to implement real-time is you will give your users a more sophisticated and improved user experience. They will no longer need to perform actions on your site to get the latest content. You will be the one that cares for that. Real-time isn't new. It's really old, actually. There was implementations ranging back from the 90s. I'm going to take a few years back and see how we implemented real-time a couple of years ago. One of the most important things when you establish a real-time connection is that you lose the spinner and all the loading indicators on your site. So you can just do a synchronous request to a server because you will have an annoying loading spinner at your mouse cursor or progress bars at the bottom. People have gone to a really long extent of research to finding out how you can disable these loading spinners. Because if you have them, people will just think your site is still loading. I'll just wait before I can interact with it. One of the techniques that people used is polling. You have different types of polling. You have short polling. That's basically when you send an asynchronous request from the browser to the server, ask it for data, and when you have a response on your request, you will send another request. So it just keeps on polling and polling the server. Another way is to implement a long polling. You'll basically send one request to the server, and when the server has new data, it will answer the request. JSON polling is one way of establishing cross-browser polling techniques. If you have up-to-date browser, you can also use XHR polling, but that's not available in every browser. Because XHR polling and JSON polling are basically just GET requests and to getting the data, it's usually used in conjunction with creating a hidden iframe in the page and submitting a form in there to submit data to the server. Another way is iframe streaming. You create a hidden iframe in the page and request a page on your server that keeps on writing tiny little bits of script text into that iframe. This will trigger a lot of loading indicators in basically every browser. So what you can do to kill those loading indicators is to wrap the iframe creation into an ActiveX object. You have a special object for it. It's called the HTML file. And if you load the iframe in there, there will be no more loading indicators. The only downside of this is that it's only available on IE. So it has an advantage of using this kind of transport because it's a streaming transport, so you will not be sending a lot of requests to the server, so less overhead. But it's only IE. Another option is plugins. I mean, every browser that you're using has some sort of plugin. It's either Flash, Silverlight, Java. And the adoption of plugging is really high. You can get like a penetration rate of like 90% of plugins. So you have a good way of establishing a good connection with a plugin. But it's really not an optimal way because plugins always use more memory than you want. And some plugins actually require extra handshaking with the server. So when you start a real-time connection through a plugin, it can take up to 5 seconds before you actually establish the connection. So it might depend on your use case for real-time. If you're building a simple chat server, it might be good enough to have just a couple of seconds of latency. But for most cases, this is not acceptable. Another way is to use the event source. It's got its fame from the HTML5 specification, but it's actually been developed much longer, and it's available in Opera 9. They're using a really old specification of it, but it works and it's streaming. It has some downsides to it. It's limited to your same domain communication, so you can't communicate with it using cross-domain. You can work around it, but you lose the benefit of using Opera for it, because you basically have to put it in an iframe again and use a window.post message to communicate with that iframe and send data over the event source. Another hacky way is to use the window.name transport. It's basically creating an iframe in your page. Again, an iframe. And you load up a page in there, and it continuously polls the .name property of the page. What you can do in the page that created the hidden iframe is just write new data into the window.name, and you can just read it out. It was first invented by Dojo, but it's a really nice hacky way to have some sort of cross-domain communication that works in every single browser. So WebSockets, why not use that instead? It's a great new technology, and it's been said to change the web as we know it. But there are good sides on it and bad sides. It's really nice that you have a full bi-directional transport, and it allows you to upgrade your regular HTTP connection to a TCP socket. So you lose all the overhead of sending HTTP headers back and forth between the client and the server. So we're going to dive a bit deeper into the good parts. It's full duplex, so bi-directional, so you don't have to establish two connections to communicate with the server. You can just use one single socket, because browsers are limited to the amount of connections they can open per site. So if you have a lot of polling on your site, you might be blocking the downloading of your images or other script resources. It's also lightweight. It implements its own framing protocol on top of the TCP. It's not that great. There's been a lot of progress made for this protocol. They actually started a while ago in 2009 and have released multiple versions of this protocol. It's even up to 7 different protocols at the moment. So it's taken a lot of time, but they finally managed to create a good, stable protocol for WebSockets. And it's really important to have good protocol for it, because if you're going to look at how many clients you can have on a polling server and a WebSocket server, you will see that a polling server has much more overhead because of all the HTTP headers that you continuously send back and forth between the server. And now the bad parts. Just like every single technology, WebSockets have some nuts and bolts. It's mainly because it's still a relative new technology, but just like always, you have the issue of browser coverage. It's actually quite decent when you think of it. It supported many default browser versions, except IE, that's always lacking. But this is just a protocol. If you want to implement only the latest protocol, you will see that the browser versions are drastically higher than a regular WebSocket server that supports all different types of protocols. And then there are the different implementation issues that browsers made. There's a bug in Safari when you connect with a WebSocket and you have a setting enabled in your network panel called auto proxy discovery. It will actually crash the complete browser or the tab. When you're writing to a closed WebSocket connection, and even though the connection says it's readable and writable and everything's open, you still write to it, it can close, it can crash the browser or the tabs. This is a bug that only manifests on iOS browsers, but it's still annoying. 3G connections are also known to crash WebSocket connection. It could be that it's related to the proxy bug, but it's really hard to reproduce these issues. But it's something you should take in mind. Pressing the escape button in Firefox will drop the complete connection, even after the page is loaded. They actually fixed it in the latest version, but it's not something you want to ignore, especially if you're building a game and people have to press the escape button to toggle a menu, or even if you have a simple model in your page and they have to press the escape button, it also will close the connection. Sending invalid UTF-8 like emoji characters will also close the connection for some odd reason. It's not a valid UTF-8, so they will just ignore it and completely drop the connection. Firefox doesn't allow you to connect from a secure page to an insecure WebSocket connection. They called it a security feature, but it's really annoying. And then you have the issue of connection blocking. They designed the protocol to be resistant to firewalls and fire scanners, but they actually did a really crappy job on it, because you can still lose your WebSocket connection if there is a firewall, an aggressive firewall between it or an antivirus scanner. I've actually done some research on this and loaded a simple page on port 4000 and sent about 10,000, 100,000 different users to it, and actually found out that 3% of all these requests were blocked. It could be that there were enterprise proxies, because those will always or normally block requests to ports they didn't configure. But there's still a large amount of firewalls and fire scanners that actually block this. It was later again confirmed by the Battlefield 3 guys who had issues with their new invented chat system that was completely based on WebSockets. And they made a humongous list of different fire scanners and antiviruses and firewalls that block or completely kill your WebSocket connection. So solving this puzzle. As you can see, it's not really easy to make a rock solid connection. That's why you will always need to have some sort of fallback for it. So the best way to do is to handle multiple transports. The reason for this is because some transport doesn't work in your browser, so you need to filter them out. You will also need to know if you actually want to connect using this transport, for example, a plugin. You don't want to have 10 seconds or 5 seconds of latency. So what most frameworks implement is a downgrading pattern. They actually start with the best protocol there is with WebSockets and then downgrade to lower, more latency sensitive transports. But as we found out that a lot of WebSockets are being blocked by firewalls, this isn't really the best option. Instead, you should be actually doing an upgrade and start with the best, most and reliable technology, and this would be JSON polling because that's mostly accepted in every single browser there is at the moment, and simply upgrade up to different transports. During when you have answered a poll from the server, you will just probe the server with a new transport, and if it successfully connects, you will use that transport. If you still want to support a lot of WebSockets because your application might be really heavy on the traffic, you can always implement an extra set of technology on top of it and do some port downgrading. and actually start with a port number above 2000 and downgrade further down. The reason for this is because there's a really aggressive file scanner that blocks all WebSockets on port 80, which cannot be detected or prevented. So I'm going to talk a bit about the different frameworks that currently are in the web. First up is Socket.io. It's developed by Guillermo Rauch from LearnBoost. It aims to have a WebSocket compatible API, or comparable API, so you have the minimal amount of refactoring when you want to use Socket.io. It works cross-domain. It works in multiple processes, multiple servers. It has a special backend written for that that uses the Redis database to communicate with different processes and servers, so you can actually broadcast a message to every single connected user. It supports a lot of different transports and has a huge community. It's one of the biggest real-time libraries there on GitHub at the moment. It has a huge mailing list, tons of people that are actively deploying it and using it in production. Then you have Sock.js. It's a relatively new real-time framework. The development is powered by RabbitMQ. They also develop high-performance message queues and brokers, so they know their stuff when it comes to messaging. It has a WebSocket compatible API, so there's not much to change but the constructor. It doesn't have any built-in logic to scale out to different servers. So if you want to scale out to different processors or servers, you have to come up with a custom solution like load balancers or anything else. Just like Socket.io, it has many different transports and works completely cross-domain. You also have Fay. It's a relatively old real-time transport. It's been developed by James Coglan, and it's a pub subsystem based on the bayeux protocol. The Socket.io and Sock.js actually use a custom protocol because they feel it's more lightweight and less verbose. It supports different transports like event source WebSockets, and it's completely cross-domain. It also works on multiple Node.js processes. It has a different Redis backend, just like Socket.io has, to scale out to different processes. Fay is also ported to different technologies like Ruby. Sock.js has been ported to Erlang and Python and a couple of more. Same count for Socket.io, so you're not really limited into using Node.js if you want to deploy a real-time server, but it's the best because it's really focused on high-performance I/O. And then there's just one more. It's Browser Channel. It's a framework developed by the guys of Google that ships with the Google Closure library. The server component is done by Joseph Gentle. He's also the guy who worked on the Google Wave project. It's not cross-domain. It's only designed for same domain transports. But if you're already using the Google Closure library, this would be one of the best options to implement. We with Socket.io found out that we have a lot of these connection issues and we really wanted to solve them. So we started a new project called Engine.io, and this will actually implement the transport upgrading instead of the downgrading, and it's a completely separate project, so different modules can be built on top of Engine.io to create your own real-time server. Socket.io, for example, will be using Engine.io in version 0.1 and implement real-time and reconnect support and multiplexing on top of it. And that was my presentation.